Okay, yesterday we talked about the Pythagorean theorem. This time we're going to be talking about the converse of the Pythagorean theorem. Here's what the Pythagorean theorem said, basically. It says, if you have a right triangle, then what do we know about the sides of the right triangle? Then I know that I can take the two legs, which are A and B, I square them, I add them up. What's that going to equal? C what? Squared, right? So if it's a right triangle, it's the only time I can do this. Well, I shouldn't say. Yeah, it's the only time this works is if this is a right triangle. Everybody with me? What does it mean to be the converse of something? We switch the what? The ifs and the thens, right? We switch the ifs and the thens. So instead of if it's a right triangle, we're going to say what? If a triangle has a squared plus b squared equals c squared, then you know it must be a what? A right triangle. Then it's a right triangle. Okay? So if they give you three sides, so this is what they're going to be doing. We'll do an example or two. Okay, you'll see it. But if they give you three sides, you're going to determine, is that a right triangle or not? So for instance, this is one we talked about yesterday. We actually talked a little bit today about it. What if I give you a triangle with sides 3, 4, and 5? So this is a triangle. All right. I don't know it's a right triangle just yet. All right. I got to figure out if it's a right triangle. So what do? How do I know if it's a right triangle? If this stuff works, then it's a right triangle. So let's do that to this. Now remember, the A and the B are the two legs. They're the two shorter sides. The C is always the what? The longest side, okay? Now again, I kind of don't know if it's a right triangle yet. I mean, I kind of do though, don't I? Because of what we talked about yesterday with the Pythagorean triples, all right? But let's just pretend I got sides 3, 4, and 5. What kind of a triangle can I make out of sides 3, 4, and 5? All right, well, let's see if I can or not. All right, so what do? I got to apply this test. What I'm going to do now, though, instead of writing it a squared plus b squared equals c squared, would you agree that c squared equals a squared plus b squared is the same thing? No. It is. Oh. Yes, agree with me. I thought. Isn't that the same exact thing? Yeah. I mean, think about it. X equals 3. Is that the same thing as 3 equals x? Yeah. Okay, would you agree? Yes. All right, so what I'm going to do, and I'm going to do this for a reason. Okay, stop the noise, whoever's doing that, stop. What I'm going to do, I'm doing this for a reason. I'm putting the c squared first for a reason. You're not going to see that until the next thing that I talk about, okay? So let's do that now. So what is the c? C is always the longest side. So which one is my longest side? The 5. So that has to be my c. What is the 3 and the 4? That's my a and my b. All right, so what I'm going to do, I'm going to do the c first, the c squared first. All right, again, I'm going to show you why in just a few minutes, promise. So let's do the c first. So I'm going to go what? 5 squared. Now, right now, I don't know if this is equal or not. So I'm going to put a little question mark there. Some people maybe put a blank right there because I just don't know if it's equal or not. All right, I like putting a question mark. And let's take the a and the b and square them. So I take the 3, I square it. I take the 4 and I square it. Let's compare. Let's see if one is bigger than the other, smaller, or equal. So 5 squared is 25. 3 squared is 9, plus 4 squared is 16. 9 plus 16, 25. Now, compare them. What is 25 compared to 25? They're equal. They're equal. So if they're equal to each other right there, according to our theorem, then it's a what? It's a right triangle. So that's how I know if it's a right triangle or not. Does that make sense? All right. So if I take the two smaller ones, square them, add them up, if it equals the biggest one squared, then it's a right triangle. Yeah, they'll give you 3 sides. Yep. By the way, while I'm thinking about it, you also have to determine if it's a triangle to begin with. It's been a little while. It's maybe been a couple chapters, but we talked about this. how do I even know if that's a triangle to begin with? There was a little test that we did. Add the two smaller ones, okay? So if I add the two smaller ones, what do I get? 7. That has to be what? More than the third side. So you do remember that, don't you? Yeah, we talked about that a little bit. I don't know, a couple chapters ago, something like that. So first of all, determine if it's a triangle to begin with. Is that a triangle? Yes, it is. Not every thing that has 3 sides. What if I had sides 1, 2, and 5? Is that a triangle? It's not even a triangle, right? Because 1 and 2 is what? 3, and that's 5. Is 3 greater than 5? No, it's not. So that's not even a triangle. You got it?
It would be an octagon.
It would be nothing. Okay? They're just 2 sides that don't meet. All right? That's the only thing that is. All right. Here's what we're going to do now. So, if c squared equals a squared plus b squared, then, what do we say? It's a what? Then it's a right triangle. Now, the next 2 things we're going to do, I think are pretty interesting. I would have probably never thought about this on my own. Probably would have never thought about this on my own, to tell you the truth, if it was just me. But watch this. If I take the longest side and I square it, and if it's less than, not equal, but if it comes out to be less than a squared plus b squared, then you're right. It's not a right triangle, but I can tell you what it's going to be. Then it's an acute triangle. All right? Just by knowing the sides of the triangle. I take the 2 smaller ones, compare it to the biggest one, squared, okay? So I take the biggest one, I square it, take the 2 smaller ones, I square them and add them up, then I compare the 2 numbers. If the longest side squared is less than those other ones, then it's an acute triangle, all right? So what do you think would be true if c squared is greater than a squared plus b squared? Exactly right. I'll just write it down. Then it's an obtuse triangle. All right, that's kind of interesting, I think. All right, so you can compare them. So it's not technically the Pythagorean theorem because it doesn't say equal, but it's kind of cool because I can tell, if you just give me 3 sides of a triangle, I can tell you if it's either a right triangle, I can tell you if it's acute, or I can tell you if it's obtuse without even drawing the picture. All right, just given the numbers, I could tell. All right, so let's do one and see what it is. So I'm going to give you sides 7, 12, and 13. First of all, let's determine, is this a triangle to begin with?
No. Yes.
7 plus 12 is 19. Is 19 bigger than 13? Yes, it is. Okay. Now that just tells me that it's a triangle. It doesn't tell me if it's acute, right, or obtuse. Okay. This is when I got to do that squared stuff. So which one do I do first?
13.
The 13. I take the C, right? That's, here, I'll show you this. Before I do this, forgot about this. Do you see how the less than goes with acute and the greater than goes with obtuse? Do you remember what an acute angle is? An acute angle is an angle that's what? Less than 90 degrees. An acute angle is an angle that's greater than, let's say greater than, more is correct, but let's say greater than 90 degrees. So it's easy to remember which one goes with what, all right? But the c squared has got to go first for this to work. You see it? So that c squared's got to go first. So if c squared is less than, it's acute. And you're like, that makes sense. Acute is less than. Obtuse is greater than, right? Less than 90, greater than 90. Remember that stuff, right? So it should make sense. Would you agree? But you got to take the C first. The C's got to go first, the longest side. So how are we going to compare this? I'm going to go what? 13 squared. And then I'm going to compare it to, I'll just put a blank there this time. Compare it to what? 7 squared plus 12 squared. Let's see what we get. Let's compare the 2 sides. If this is less than this, it's acute. If this is greater than this, it's obtuse. If this is equal to this, then it's, come on, it's a right. If it's equal, it's right. Okay? All right, let's see what happens. Let's see what the numbers say. 13 squared is? That's 169. Compare that to this. What's 7 squared? 49 plus 12 squared, 144. Okay? So we've already simplified that. Let's compare it to this. 144 and 49 is 193. So let's compare 169 to 193. It's less than. 169 is less than. So what kind of triangle is this? It's an acute triangle. It's acute. All right? There you go. So look, let's say this was on a quiz. I'm making up a number. Let's say it's number 5 on the quiz. All right? And they give you this thing, and the only thing you write is acute triangle. Why? That's right. You didn't show me how you got that. Okay? I would mark that wrong because you have to show me. You cannot just guess. I don't want you just guessing because you could guess, right? You got a 1 in 3 chance of guessing, right? You got right, acute, or obtuse. So you got a 33 1/3% chance to get it right. But let's get a 100% chance, all right? Do the work, know what you're doing, then write down the answer. So if you show all of this stuff and you show the answer acute and you circle it, that would be correct. Then I'd give you credit for that. We got it? All right. Let's do another one. Let's just make up one. We got some time. That's rare, isn't it? Let's make up a triangle. Give me a side. 7. Give me another side. 6. Okay. And then give me another side. You got to make sure it's a triangle. Okay. Is it a triangle? You think so? How do you know for a fact? Nate, you said it pretty quickly. Add the 2 smaller ones, 6 and 7. That's 13. Is 13 bigger than 10? Yes, it is. So yes, it is a triangle. Now let's see what kind. Let's see what kind of triangle it is. All right. So what's the first number I'm going to use? No. Why 10? Well, we don't know it's the right triangle, so I don't know it's the hypotenuse. It's the longest side. It's the C. All right. It's the longest side. So I take the 10. And that's a common mistake people make. A lot of times they take the smallest one or just the first one. All right? Take the longest one, the biggest one, 10. And what do? We square it. Let's compare it to the other 2 squared. 7 squared plus 6 squared. What's that? It's 100. All right? What's this? 49 and 36. So what's that? 15, 7, 8, 5? That's 85. Compare 100 to 85. 100 is greater than, so what kind of a triangle is this right here? It's obtuse. That's right. Pretty simple, isn't it? Yeah. You just got to know what to do. The math is not hard at all. You just got to know what's going on here. Again, you take the c squared, compare it to the a squared plus the b squared. So make sure you put the c squared on the left and the a squared plus b squared over here on the right. Then you can compare them. If the left side is greater than, it's obtuse. If the left side is less than, it's acute. If the left side is equal, then it's right. And that's all there is to it. There will be, if I remember right, there will be 2 questions on the quiz, all right, whenever we are ready to take the quiz. I don't think we're taking a quiz this week, are we? Probably next week, all right? There will be 2 questions with this on here. And you have to show what? Your work. Show your work. All right? There's a reason that teachers stress showing your work. It's to show that you're not just cheating off somebody, you're not just guessing, you're not just memorizing a problem from the homework, okay? You're showing me that you know how to do this. That's why we have you show your work. Does that make sense? Okay. All right, your homework is 13 to 19. So it's section 7.3b. And it's numbers... Oh, wait a minute. It's maybe not that. Hold on. It's, yeah, I was right. 13 to 19. 13 to 19. All right? That's your homework. That's due tomorrow. Tomorrow, we are going to do a worksheet with this stuff on there, and I'm going to show you a little video. All right. Remember I talked about, shh, hey, guys, hey, we have not dismissed yet. Have a seat. Josiah, have a seat. So listen to me. Tomorrow, we're going to do a worksheet. We're going to go over this, and then I'm going to show you a video on the two girls that proved the Pythagorean theorem a completely different way. So remind me, okay? Make sure you remind me to show you that video, okay? I think it's pretty interesting that kids in high school did something that hasn't been done for years and years. I think it's pretty cool. All right, there we go.